Welcome to Flat Earth Debate. I'm your host, Nathan Oakley, and if you are new to this channel, or you are amongst the 50% of the people watching this who have not done so already, be sure to subscribe and hit the bell notification icon to keep up to date with the Flat Earth Debate. If you would like to support this show, there is a super chat that runs alongside the show while it is live. And most importantly, if you would like to join the debate and express your views on the shape of the Earth, simply mute the page you are currently watching, then click the link in the info box below this video. There are a couple of rules in the Hangout. Number 1, please do not swear. If you do, you will be ejected. And if you are, please do not try to rejoin the stream using sock accounts. You will be warmly welcomed back on the next stream. Now I'm about to transition across to the Hangout as we do have some guests who have already turned up, so I'll welcome them individually in a moment. But I would encourage anybody who is currently watching this live stream to please share the show. Sharing is probably the most important thing you can do as far as I'm concerned as a viewer, as it increases the live audience, and that in turn increases the likelihood of a more diverse panel. So please share the show. And one last time, if you are new to this channel or you have not done so already, be sure to subscribe and hit the bell notification icon to keep up to date with the Flat Earth Debate. And with that, I will introduce you to our panel members. So we have been joined by Brenda. How are you doing, Brenda, first and foremost?
Good evening.
Good evening, Brenda. And we've also been joined by Arwin. How are you doing, Arwin?
Hello, Nathan.
Good to have you here. And we've been joined by Curvewater. How are you doing, Curvewater?
Wonderful.
And last but not least, we've been joined by Mr. Flat Curve. How are you doing, Mr. Flat Curve? Joseph. And Ali B.
Yeah. Hi.
How are you doing, Joseph?
Yeah, I'm doing good.
That's good. That's allowed. Well, good to have you all here. Let battle commence.
Ali fell down.
Hey, that picture of yours, is that a real ruby?
I don't know. I just took a stock image.
Oh. Okay.
I was into geology when I created this account, so
All right.
I just haven't gotten around to changing it. But yeah, so would you like to start us off?
Me?
Yeah.
Oh, dear. David has arrived.
Oh, hold on. Big one hurt.
Been joined by Mr. Flat Curve. We've been joined by David, and we've been joined by Paper Explanator. So if we start with who was in first, David. How are you doing, David? Earth to David. Maybe not. We'll start with Paper Explanator. How are you doing, Paper?
Hey, Nathan. You alright?
Very good to have you. And last but not least, Mr. Flat Curve. Can you say a quick hello?
Hi, Nathan. How you doing?
Very good to have you here. Right, that's that until we hear from David.
Can I just say I immediately joined because Ali B, I've been dying to ask Ali B a question for months.
He's been in and out. He may come back.
Oh. Dying to ask him a question. Never mind.
I'm sure David can answer it.
Oh, you see it.
Perfect timing. We've been joined by Ali B. Good to have you here, Ali.
Yeah, how you doing?
Perfect. We've got a question from Paper Explanator specifically for you, so maybe that'll kick us off.
Ali, how are you doing?
Not so bad, mate. How are you?
Not so bad.
You're not Chris.
Sorry?
You're not Chris F.E. Jackson.
No, not Chris F.E. Jackson.
Yeah, I know you're not. I know you're not.
I've just been dying to ask you a question, Ali, because you're a flat earther who believes that the moon landings
Yeah.
Yeah. Okay. And you also don't believe in gravity.
Yeah.
Okay, so you think that things just fall down just because of their density?
Well, they don't. Nothing falls in space, right? Because there is no up and down.
No, on Earth.
No, because of pressure. The surrounding air pressure actually keeps us on the ground.
That's what pushes us down.
No, that just yeah. Part of it. It's obviously a deeper explanation, but that's what I've come up with so far because of the fact that when we go into a lower pressure of space, we float. So
Nathan.
Gravity, I say it's pressure because there's a lower pressure, therefore we float in space. We don't float here. There's the variable is the pressure. You say gravity, but the variable is pressure in my eyes. So therefore,
So okay. So
Nathan.
if there's very little pressure, do you think there's very little sort of gravity, or well, what you would say manifests itself as gravity?
but I don't believe it's gravity. I don't believe that's the force that Einstein says or Newton says. It's I think they've totally got that wrong.
Okay.
They're talking about something that doesn't work.
Do you believe there's an atmosphere on the moon?
I've not actually even thought about that, to be quite honest. They say there's an atmosphere on it, right? But I wouldn't know. I haven't looked at that, but that wouldn't make any difference to me.
Okay.
But
So
apparently there is. Is there? I think they say there is.
no, there is no atmosphere on the moon. Okay.
Oh well. Wait a minute. Actually, I'll have to pull you up on that. I'm sure I've read that.
Wait, Nathan. I'm
there
pretty
is-
sure you still need to start up the stream on YouTube.
Right. Wait a minute.
Just wait.
Yeah, right. But I do believe they actually say there is a small amount of atmosphere on the moon.
Well, yeah, the density of molecules. Yeah.
All right, so there you
You
go.
call
So
it an
there is.
atmosphere. I mean, there is
Right,
gravity
okay.
on the moon.
No. So there is atmosphere then, right? Okay.
Well, I mean, there's atmosphere in interstellar space, if you want to call it that. There's there's
That's
a few
fine.
molecules. There's a few molecules per cubic meter. If
Yeah.
you want to call that an atmosphere, then fine. Okay. So, I mean, let's just get atmosphere out of the way first. I mean, you agree that the atmospheric pressure at ground level is about 14.7 psi?
Well, that's what they say. But so, yeah, I suppose I'll go with that. Yeah, whatever.
You can
whatever.
put any barometer or pressure
Yeah,
pressure meter. It's 14.7. That's fairly trivial. And you go higher and higher. I mean, even in a car driving up a hill, you feel your ears pop and things like that. And we know that the atmospheric pressure at the top of Mount Everest is around about 4 or 5 psi.
Okay.
Okay, so it's reasonable to assume that as you go up and up and up, the atmosphere gets thinner and thinner and thinner. And so it's reasonable to assume that if you went higher and higher and higher than Mount Everest, it would eventually reach. Technically, it would approach zero.
It would take a very long time.
Yeah, that's what I'm saying. I don't. Yeah, but it might actually stop approaching zero, though. You know what I mean? It might hit a level. It hits a level. Like the fact is, right? When we are down here, we don't float, right? Mm-hmm. When we leave the Earth's atmosphere, we start floating, and we don't. I don't believe that we fall anywhere because there is no up, down, or anything in space.
I think you're confusing floating with being in orbit. Are you thinking of the people on the ISS?
No, I'm not. No, I'm not talking about orbit. And I'm talking. That's not the reason that they float. And it's and I believe, or I think. They don't believe they don't float because they're falling around. I believe they actually float. It's not because they're falling around the Earth or anything like that. I totally don't agree with that.
Do you think the ISS is real?
Oh yeah, of course I do.
You do? You believe it orbits the Earth?
Yeah, I believe it goes round in a circle.
Okay. Do you know what's holding it up? If you think the Earth is flat,
it's floating like every other thing up there. So
what's making it go round in a circle?
It could be magnetic. What do you call it? Currents. Like a moving field.
Magnets are attracted.
Wait a minute.
Do you have proof that wasn't there before the ISS was put up there? Do you have proof that light wasn't going around before the ISS was put up?
Ali's talking, please.
I'm asking a question over here.
The ISS was put up there then.
Right, can I finish? Right, if you know that Null School, that animated thing where they put all the data from satellites onto the thing. Well, if you look at a thing, there's a thing called the polar anticyclone or the polar vortex. If you look at that, right on the outer atmosphere, there's winds traveling at about 200, 300 mile an hour.
Where's the newspaper article that shows that was the first day? The first day you could see that thing flying around. Is there a newspaper article that has that?
Right. So anyway,
Guys, come on.
my hypothesis.
No, I'm serious. I want. Is there a newspaper article where
Guys,
it told
you
people
just
that
have
they
to
could see
pull
the
apart
ISS
the
flying around?
gravity and the
Why is that such a
gravitational
hard
pull.
question to answer? I mean, it's
Because somebody
it's
else
just
is talking, David. You're being rude.
no, but we're
Yeah.
talking about that. Go ahead.
Yeah, I'm going to interrupt you
let
as well. I'm really sorry to interrupt you as well. But yeah, we've been joined by Al K. Good to have you here, Al.
Evening, Nate. I thought I'd take up that last space.
Good to
Yeah.
see you.
So please continue, Ali.
Regarding what I've explained. So all right. So there's air or currents or whatever they are that are circulating. When it had the
They can't be air currents. They can't be air currents because there's no air up.
Well, the currents. Okay, then if they can't be currents, it's obviously it's high winds. They're called they're called polar cyclones, right? And there's one over the North Pole, and then it shifts to the South Pole every 6 months when the equinox or whatever happens, right?
And what makes up these?
Right up. Wait a minute. Listen. That's right up on the very, very edge of our atmosphere. So I've got that. So my meaning is that somehow they're circling around within that kind of current. It could be hydrogen. It could be some kind of cooled gas or something. Some kind of system that's.
Does this include the sun?
Say again.
Does this include the sun?
Well, obviously it's out there, isn't it? So everything out there floats. So yes, it does. It includes everything, the planets and everything.
I see. Okay.
The stars, I don't know about because I don't.
Have you tried testing? Have you tried testing your theory that gravity is actually pressure?
How can you test gravity in a gravitational field?
How can we test it?
Listen,
Vacuum chamber.
Excuse me. If we're in a if we are within.
Has anybody heard of a vacuum chamber?
Exactly.
Yeah,
I have a,
but that's still that's in a gravity.
There's no newspaper articles that say for the first day you could all the people in the world.
But
Can we
that's
get an answer on the vacuum chamber?
That's a gravitational field, though. The vacuum chamber is still on the Earth, which is within a gravitational field.
Sorry to interrupt you guys. Sorry, just bear with me, guys. Just want to make. Sorry, I'm going to have to turn you all down just so you can hear what I say. Sorry to interrupt you all. Right, Joseph, don't mute people. That's not done here. You do not mute people. If they're talking over somebody, tough. That's how it is. Don't mute anybody.
all right, sorry.
Ali, does gravity exist or not, Ali?
Well, not Newton or not how they've described it, and that's not. No, I don't see that as gravity. As I say, I've told you pressure.
But things still fall down in a vacuum.
Is there such thing as reverse gravity? Is there such thing as reverse gravity? How about that?
Right, but wait a minute. Listen, but the only constant that's got removed out of there is the pressure, not gravity. Because it's how can you measure gravity in a gravitational field?
But
There's no gravitational field.
It is because it's in.
No, there isn't.
Yes, of course it is.
No, there isn't.
What does gravity suddenly become selective and not even enter into the?
No such thing as a gravitational field. You don't believe in it.
No, but that's what you're saying.
No, but you're saying it doesn't exist.
I'm talking. Yes, but
you're saying gravity is really pressure. So if we take a vacuum, if we take a container, remove all the air from it, the container has no pressure in it. Anything inside of the vacuum chamber should put up to the top. Your theory is refuted. You're full of crap.
Ali, I have a question for you.
In a gravitational field, that's absurd.
There's such thing as a gravitational field.
What would happen if you were in that chamber, huh?
Ali, I have a question for you.
What would happen to the human body if it was in a vacuum chamber, huh?
Ali, you keep stating a gravitational field, Ali. You keep stating a gravitational field, but yet you don't believe in gravity.
But you're using the vacuum as a chamber, but I'm debunking.
I have a question for you.
So it's either a vacuum or it isn't, Ali.
Right.
Yeah,
Ali, I have a question for you.
Right. Well, wait a minute. But
Let Joseph take a shot.
The vacuum is in a gravitational field, as you would call it, right? It has to be. If it's on this planet,
on one side,
in space, away from any mass. Do the experiment in space, away from any mass.
Ali, in 1 second,
according to you. Ali, we are on Earth's gravity.
Ali, please stop rambling.
Ali, in 1 minute you're stating that pressure keeps people on the Earth, and then you say in a vacuum things still fall down, and you say that's because it's in a gravitational field. Do you not see the total contradiction in what you're saying?
Yeah, but the thing is, for some reason we start floating out there. Now I put it down to
Ali, I have a question for you.
He doesn't understand the.
Oh, but I do.
What was the first day that they showed it on the news that you could see the space station? Does anybody know that?
Thank you, David.
What day was that?
Hey, Joe, word it out, Matt. Word it out.
No, we're not
interested in anything you have to say, David. Go quiet.
All right. Ali, I have a question for you. So let's say let's just hypothetically say there is no such thing as gravity, and what's keeping us on the Earth is pressure. And in space, there is no pressure. What causes comets and meteorites and whatnot to fall into the Earth's atmosphere? Because if nothing's making them fall, if there's no pressure in space, well, then nothing should be making them fall.
They're fictional.
Well,
nobody knows that there's space. All there is thinner air, man. That's what we know.
No, listen, if I fired a bullet in the direction of a target, I'd hit the target. So obviously the meteorites that fall here were aiming for the Earth. So what's the big deal?
All right. Okay, hold on. Ali, in your own language, okay? Don't adopt our language. In your own idea. You've been asked why things are pushed down to the Earth. You say pressure.
Yeah, it's
atmospheric pressure.
Yeah, it's holding us here. Yeah, plus.
Okay, thank you. And now, next, Ali, is you have in a vacuum chamber on the Earth, relatively like zero pressure. Okay, you don't have pressure in a vacuum chamber on the Earth for a brick to start floating.
Your man just said that when on Mount Everest it was 5 psi. What about that? What about that?
In your own words, Ali, can you tell us what it is that you believe causes the objects to stay on the bottom of the vacuum chamber? Why don't they float in the vacuum chamber? Or why do things still fall down in a vacuum chamber on Earth when there's pressure is not your answer? So what do you have, please?
Well, that's what right. I'll answer that. That's exactly what I'm saying. I believe there's some kind of gaseous substance or some kind of way that things are floating up there, but it's nothing to do with lack of gravity and pressure.
I got the answer. One way's up and one way's down. Ding, knockout.
David, you asked me before which way was up and down, and you said it was north and south.
Two ways to keep things up.
Do you know what pressure
you do it with magnetics?
Do you know what pressure is, Ali?
Or it's purely light-based.
Do you even know what pressure is, Ali? Do you know what pressure is?
I'm going to go away and think about that. What
you don't know what pressure. You don't know what pressure is.
No, I'm not talking to you, Brenda. No,
but you don't know what pressure. You don't know what pressure is, do you?
What you were saying, curved, and what you were saying.
You have no idea. You have no idea what pressure is.
I'm going to go now, and I'm going to. I know it's not gravity, but now I'm going to look a bit.
But you have no idea what pressure is.
Fine tune my model.
Good idea.
No clue what the word pressure even means. You have no idea in your head.
Absolutely not. No.
Yeah.
Your people were just saying that on Mount Everest, people up there were at 5 psi, didn't you?
That's correct. Yeah. What's the problem?
So what do you say? We're sitting at 0 on the Earth, right?
In a vacuum chamber, David, how much does ISS weigh per square inch?
No, I'm just asking a question here, trying to follow you what you're saying.
Okay. Hey, you know what? Your questions are like really good, David. I like them.
About what day was the first day you could see the ISS in the sky? Anybody got that?
I tell you what, if people can't recognize,
if you type into Google day 1 ISS could be seen, there's no search result that comes up. Why is that?
Why don't you look it up?
David? I just did. It's not available, but you're arguing for something that there's not even a newspaper article for.
Someone answer him.
Well, I would imagine it would be shortly after it was launched, right?
Yeah. When? David, are you using www?
No, because it went up there in pieces, didn't it?
Yes.
How do you?
If it went into pieces, so there would have been a point where that thing was big enough for people on the ground could have saw it, right?
Yes.
So where's that? What day was that?
Oh, I just looked that up. So
you're arguing for something that you think is so great, but you don't even know what day was the first day you could see it. Because from Earth, this magical thing floating around up there.
Because I don't know what it was announced.
David,
you're a troll.
David,
I am a troll. Troll. Thank you.
Troll.
David, I have.
We got.
David, Joseph's trying to answer you, David.
Go ahead and go to the next subject. You already lost that one.
It says 15 years ago, on the 20th of November, 1998, is when it started. So yeah.
How did you find that? Wasn't the question. The question was, when was it first visible? The point being that it went up in pieces.
Okay. When it was first visible. Okay.
Yeah.
Okay. I'll keep looking then.
Well, would the first stage have been visible?
To some people, probably.
Many satellites smaller than the ISS are visible.
Who was the first astronomer to see it?
Galileo.
Public. Yeah, Galileo. Yeah, Curve got it right.
There are many satellites that can be observed from the ground. Thousands of them. Actually.
Let's see.
When was the first iridium flare witnessed?
Well, that one I don't know. That one. What is an iridium flare?
But guess what? They're still there. The Iridium satellite network. You get bright flashes off of them.
Whatever's floating up there, if anything, looks nothing like the CGI we get to see when we look it up in Google.
Did they have CGI in 1968, Arwen?
Yeah.
Okay, so the ISS was completed on the 20th of November, 1998. So I'm assuming that would be the first time that you could see it, as that is the day it was completed.
You don't think that would have made the front page of newspapers all over the world if it had been the first day that everybody could have saw it?
Well, I mean, they had already been talking.
I mean, you don't think that would fill up Google search results when you put on there first day ISS can be seen?
You don't care about space exploration. Why would they?
It was 1998, my guy. The internet wasn't.
That's why y'all are on here arguing. Is for all this science stuff.
No, it's because people come.
Got you all convinced you live on a spinning ball over here.
It's because people.
The art of animation, painting has been perfected for over centuries.
Arwen, there was no CGI in 1968.
I've got to admit, it is a good question because, you know, it's farcical to believe that the last screw went in and then suddenly you could see it. That seems ludicrous.
No, CGI is the only.
You know, it's
computer generated.
To assume that the last screw gets screwed in and suddenly the thing's visible, that's nonsense. But you'd think.
No, I'm saying, but what I'm saying is that it was completed on the 20th of November, 1998. That means that it's the size it is now. Therefore, around that time would be the first time you could see it. We can estimate, we can give or take a week. Now, that gives you a time range. And if you want the very exact specific time, well, you're kind of asking for something a little ridiculous.
How about the New York Times? You don't think the New York Times had that in the newspaper first time somebody's seen the ISS?
No,
first civilian to photograph the ISS floating around. That would
because everyone knew it was up there already.
Good news.
Most people have more of an education than a third grader, David. These things are not remarkable. Things are not remarkable.
No, see, the thing is, you also have to think about they had already been getting news about the ISS being built for months and months. So when it was completed, okay, that's cool, but we already have kind of gone through the craze of it. It wouldn't.
So why would you believe it was even there until the first time you saw it? I mean, wouldn't that be that? You can't tell me there wouldn't be a wow effect when people all over the world pull their telescopes out and started seeing this thing fly around. You don't think it made the front page of?
Have you guys ever considered
the New York Times or something?
Why don't you
go see in the heavens as the ISS?
Why don't you go to your library, David?
It's just a heavenly phenomena that has been
around
forever.
Go to your library. Go to your library,
establishment
David,
used.
Just ask Lewis. He's got the encyclopedia.
David, my God, dude.
Well, you know, you moderate him. He's yours. David, go to your library and scan microfiche records for newspapers around that time.
Go ahead, Arwen. I was listening. I'm sorry. She was talking crap over there. I gotta go ahead, Arwen.
Sorry. Yeah, that's all right. I was just saying that what we see, the shape of the ISS may have been based on a heavenly phenomena that just happens to look like that, like a snowflake type of light or wandering star, and nobody knows what this is, but it could have been around forever, and
we know it's the ISS.
They just used it.
It might have been
their system.
It might have been
very clever invention.
Unicorn too.
You just erase all ancient mentions of this star phenomena, and you have the ISS.
It might have been shaped like My Little Pony.
Arwen, what would they gain from doing that? A. B, think about the cost of doing that. And C, think about how hard it would be to go across the whole entire world and find every little bit of information about this supposed ancient structure.
Arwen, you got them stirred up now, Arwen.
It doesn't have to be that hard.
Knock them out,
if you have a visionary that sees like hundreds of years into the future, these kinds of things. And that's what these people deal with. They build on visions of the future, and they're making it come true.
But
they're using whatever.
What do they get?
Whatever's up there. What they gain from it, they get a perfect cover. They get the perfect cover of the heavens for a space project.
Okay, but what are they?
Nobody knows what it was, and this is it now.
Well, it's the ISS. You can.
That's what it's become.
Yeah, you can
erasing the previous history.
You can see it through a telescope.
Yeah,
Man-made
and it's probably been seen through telescopes, that exact phenomena, back in the 19th century even.
No, why was it not seen in the 80s
it's been around for a long time.
You act like astronomers all over the world are not looking all over the place in the sky. How has nobody seen this before and noticed that there's this unknown thing flying around the Earth 14 times a day?
I know it's a conspiracy.
It's not always that visible.
That's even crazier when you think about it. Doing it 14 times a day, and they didn't announce people were seeing it. That's even worse.
You don't see most of them from any one location.
Science, people have started staring at the stars all over the world. So much is involved in that. But before the time, they were just stars. So nobody was always.
This is not a star. It doesn't act like a star. This is a UFO. You understand? This would be a UFO.
Just
like what other flat earthers on here, Arwen?
If we did not know that NASA had put this thing up there, it would be a UFO that people see all over the world on a regular basis, on a regular predictable basis in an orbit. An orbit that degrades, Arwen. An orbit that has to be boosted periodically to keep it from falling to Earth.
Yeah, sure.
So
sure. And credulity, that's a wonderful weapon, Arlen.
Well, see,
why do you wield it well. Wonderful story.
Why do you think your fantasies have any kind of correspondence to reality?
Well, why don't you believe popular science?
Like a Jesuit. This is what they do.
Arwen, why don't you believe
manipulate past things that exist and then change the history of it, and they do it retroactively.
But why, Arwen? You have to think. No. You have to think the cost of doing it.
Because they're building this fake reality.
No, but why? What would be the point of this?
The fake reality, Arwen.
They're just. It's
okay,
what the devil does. Confuses everyone.
Okay, so
makes everyone believe the exact opposite of the reality.
It seems like you're going back to
about that. You're definitely confused and living in a fake reality. There's no question about that. Yeah,
sure, Brenda.
No, it's true. You're living in a fake reality.
That's fine.
You can't rationalize.
Yeah, I value your opinions about my sanity so much.
Guys, even if we disagree, let's keep it civil, all right?
Yeah, but you can't.
Arwen is a fanaticist in that.
I like the KISS formula. KISS formula works real good.
Maybe a fantast, because I do wander in all directions.
Yes, you do.
That is true.
That is true, and you have these fantasies that you perceive to be reality, and they're not.
I just see them as possibilities.
Well, everything is possible.
Yeah, a lot is possible, not everything.
But that doesn't mean
eventually you start to learn how that fractal works.
But your story is not plausible, Arwen.
Hey, Arwen, could you please explain that to them again? I don't think they understood what you're talking about.
Neither
what I was saying was
okay.
that
We're on the same ground.
what I was saying was that the shape of the ISS, this very distinct, symmetrical star snowflake-like shape, may be a natural phenomena that is part of the heavenly bodies as a planet,
like a
wandering star, as it were, but of a different type, of a different signature, that has been around for an eternity. And through the monopoly over astronomy and combining it with space travel plans and space station in orbit, a fantasy that they were going to make real, they decided to erase all the history of that star-shaped, that snowflake-shaped phenomena and replace it with the space station, the ISS, and they did it magnificently.
Anybody even listening?
Right, sorry to interrupt you guys. Just wanted to introduce
Ding,
Gem Panda.
knockout.
We've been joined by Gem Panda. How you doing, Gem?
I'm Gem Panda. You just missed it. Y'all just got knocked out over there.
Just give him 10 seconds, just so I can check his levels.
David,
how you doing, Gem?
David. You remember spoke to you
Al, I need literally 3 seconds of him to say something so I can check he's not a million times louder than everyone. That's it. That's all I need. How you doing?
I did speak. Sorry.
Go ahead.
Is that okay?
Everything okay?
Perfect. That's all I need. Thank you very much. Thank you for your patience.
Right. David.
Yes, sir. Go ahead.
You remember the last time I mentioned road grid corrections to you?
Yes, sir.
Have you looked into that at all?
I have not had time. I've been out there on the road myself.
Right. Oh, I haven't looked into it much myself, but I had a quick look. Right. And it's actually something that stems from the Public Land Survey System, which you can look up if you want. But this is a system that was initiated by Thomas Jefferson. It's called the Jefferson Grid. So this is, an old system of surveying the United States, and the purpose of it was to parcel it up into even squares, essentially, of land for everybody to own. Okay?
I got you.
And so, it's an old system. It's been going for a long time. And it's got nothing to do with NASA or any of this stuff. Okay? It's all ground-based. And if you look into it, you will find that it has explanations in there concerning the system that, cause it's grid-shaped, but it's actually being laid out on a sphere. They would run into problems every so many miles, mainly because the lines of longitude converge. So instead of getting perfect squares, they were getting sort of trapezoid shapes. So this is something that you can look into if you want to, and if you actually genuinely want to look at something Earth-based regarding problems with the shape of the Earth.
And being a driver, take a little more time on that. That sounds interesting.
Being a driver, it should interest you, I think, because as I say, it's specifically the grid system for North America, and I think parts of Canada are included.
They've had all those big surveyors that come on there that do those big tracts of land, so there is no curvature. So,
what type of surveyor? I mean, there's two. You get plane surveyors, you get geodetic surveyors, and it's geodesy is a whole profession.
I'm not sure. I've just listened to a few interviews, but other than that, I'm not sure.
Well, anyway,
difference, David.
I'm no expert on it. It's just what I've looked up, and I thought it might be interesting. It's something I never see anybody else really talking about either. So, it doesn't matter whether you're flat or globe. I think it's something that people should look up.
Yeah, well, I'm definitely going to look that up.
Where'd you hear those interviews, David?
Mark Sargent.
How did I know that?
Plane surveyors then.
Mark Sargent's had a lot of interesting people he surveyed or interviewed.
They're very interesting. They tell some tall tales.
They sure do.
Yeah, they do.
They tell some flat Earth truths is what they tell.
Same thing. Flat Earth truth, tall tale. Same thing.
David, what made you start believing the Earth was flat?
Don't try to start backing me in a corner. You know what'll happen over here.
No, I'm just asking you a question.
Good question.
I still want to know when you can first see the ISS. Y'all don't try to switch this back on me now.
The ISS will have been visible as soon as the main part of it was put in orbit, same as any other satellite.
What? Anything that they send up is going to be able to land. I can tell you that. They're not going to put that kind of money into something that's just. It's got to be able to come back down because it's going to have to have repairs to it.
Yes.
Yeah, they go up there to repair.
But they don't go up there. They don't go up there to repair, man. How are they getting up there? They're shooting a rocket, and the rocket is supposed to get up there and dock with this thing, right? They're not using an airplane to dock with it, right?
Mm-hmm.
They used to. The space shuttle used to dock with the ISS. There are photographs of that.
Have they stopped maintaining it? Because I know that we're not sent or
stop maintaining what?
The ISS. Like, I'm pretty sure the crew has been there for a while now. I think the next launch will be.
They sent up a rocket yesterday.
Yeah.
Oh, really?
Yeah. Yeah.
CRS 13 or 14 or whatever it was.
So they're gonna crew switch soon.
No, they're not crew switching. This is just supplies.
Ah, all right.
Is it one of those kind of rockets that can land itself? Does it go up there and then come back down and land itself?
Yep.
Probably.
Okay, I'm just asking.
Yeah.
Oh, the footage is all there. Look at it on space.
I know we saw it. That was a good show.
It looks fancy. These guys, I love it.
Footage was all there.
It's the dream, baby. Keeping the dream alive.
What's that? Dream of what?
The dream of space travel and expanding and mysteries out there.
Yep, we got to let it go. We got to accept the reality that it's just a natural snowflake-shaped object that's been in orbit for God knows how long.
Yeah.
Right, Arwen?
And
you don't have to, but it may be a possibility.
No, it's not a possibility.
No, of course.
Everybody just forgets that we're only talking about 5,000 miles that has to be gone across.
What?
It's only 5,000 miles that has to be gone across to prove the flat Earth. Okay.
What are you talking about?
And I'm not sure if it's north or south that you got to do it, but all you have to do is go past South America, because they say it's 12,000 miles on that side. On this side, on the North American side, it's 12,500 miles from the top to the bottom. So
that's the pole, Dave.
You have to just go 5,000 miles to the next land mass, either north or south, in a straight line, and it'll prove y'all's point. But nobody's done it. Have you noticed that?
How is this going to accomplish anything, David?
How come you've never seen anybody do it? You have all these people out here fighting for the ball Earth and flat Earth, and flat Earth hadn't done it. To be honest with you,
5,000 miles is.
It's not very far. Distance. It's not very far at all. If you really think about it, it's like going.
We don't need to, because we already have enough proof. Who needs?
Where's it at? Show me that proof you got. Let me see that proof where somebody's done that.
Well, the thing is, you don't.
Let's see where somebody's went over the North Pole and the compass flipped, or went 5,000 miles and went 5,000 miles south past.
How is that different on a Earth, David? How is that different?
How is that David? We have a lot of
your calculations come from your ball.
No, okay. David, can I finish? All the science that we have, all the geography, points to having a globe Earth, and that is our proof. However, you flat earthers say that proof isn't correct. So when we try to hand you proof, if you just knock that proof aside, well, then you're not really accepting our side. You're not trying to look at our proof, because you're saying that proof you're predetermining that proof to be wrong.
Now, where's an explorer at? Where's a real explorer? Somebody that would actually have the ability. I mean, you have to have a lot of preparation to do something like that, and you may have to have a team to do it. But you got to understand, somebody could walk 5,000 miles or row a boat I mean, a human body at a prime peak of 25 years old you could easily go 5,000 miles on your own somewhere. You know what I mean? So when is somebody actually going to go that 5,000 mile route?
You have the experience.
You've
driven over 1 million miles as a geodetic truck.
Yeah, but I'm not. I was pretty strong at 30, 35. I'm 50 now, so I don't know if I could do it or not.
5,000 miles in any direction.
It'd be tough to do it now.
Is it 5,000? David, are you asking for 5,000 miles in any direction? Or what? Or is there a specific direction they'd have to travel?
It probably has to go north or south because you got to have one landmass. You got to have one landmass that's half the globe. Okay, half the landmass, half the world is covered by North and South America, right? So that's 12,500 miles.
No.
Okay, either you go straight over the top or you go straight under the bottom, and all you got to do is go 5,000 miles.
Half the world is covered by North and South America. Okay. Did you really just say that?
Yeah, no.
It's not.
If you go from the North Pole, to the South Pole, there's land on this side of the world, okay?
Yeah, but that's not North and South America. You really
that's North and South America from the top to the bottom. You could drive from the top of the pole to the bottom of the pole on this side of the world.
What about on the other side of the earth, David?
No,
that's what I'm asking you, okay? You have no proof. All your maps line up side by side. All planes go east and west, okay?
So, David, what are we looking for?
Okay, so what's your point? Ding, ding, knockout again.
What are we looking for when we drive 5,000 miles in this somehow straight line? What are we looking for?
We're looking to get back where we started at. You say we live on a ball, isn't that right?
You're not going to get back where you started from driving in a straight line 5,000 miles.
It's going to be a lot more.
But you're gonna have enough proof after 5,000 miles to know where you're at. Okay.
I'm writing this down, David. I'm writing this down. I'm cataloging your thoughts and ideas because I'm
not worried about you catalog anything. You don't have no proof anything. You have no proof other than it's just like the ISS. Right. You can't even tell me the day it started up.
How do we get
you sit there and believe in that stuff? Okay.
David,
very well.
You can write down what you want about me. I ain't worried about it.
I'm gonna start a GoFundMe to get this geodetic trucker survey done. Now, what is it that we're looking for? What's our methodology here? What are we looking for? What do we find by driving 5,000 miles?
It's probably less than that. It probably 2,500 miles. You figure it out.
Well, what are we looking for?
Hey, David, let's cut to the chase. Let's take 100-foot of fishing line.
Man, you say the ball's 25,000 miles around. You say we're riding upside down and going around the world, and there's people walking upside down from us. So what do you want?
We're going to get in a big swimming pool. You can take a shallow end. We'll pull the fishing line straight, and we'll see if it's flat or if it's curved.
We had this. It was just like last night. We were talking about those trains that you could line up 25,000 trains and to go all the way around the world.
Are you ready for that?
Some fun.
You don't think there's 25,000 trains in the world? You line them end on in, and you think they'll be riding around a ball, huh?
We're falling into his silly little trap.
Oh no.
He's a troll. He's just a
Paper
troll.
Paper. What happens if you pull 100-foot of fishing line across water?
He's a troll.
Swimming pool.
If he's a troll, he's a troll.
Is it going to be flat, or is it going to make it look like the water's curved?
Or when you still on here?
100 foot. Wow. You'd need a very accurate.
Come on, take over here for a minute. We got to wear them out tonight. They like to come on here. You know they do.
Over 100-foot swimming pool.
I can barely even make out what you guys are saying.
Fishing line, you're not going to pull it tight. It's going to curve downward. It's going to show curvature. Right, David?
David's just
You're exactly right about that.
Yeah, I guess we're not. So we're not going to. So we're not going to talk about fishing line test anymore, David.
He's just having some fun.
That's why we're all here.
We're having some fun at the Flat Earth OK Corral tonight.
Hey, David.
David, you're
ding.
You know you are.
What is this about?
Oh,
the stuff he's coming out with is so utterly ridiculous.
It's not worth it.
Obviously a troll. It's so obvious.
I'm a truck driving troll over here.
No one can be dumb as you. The only thing I'll say, I don't know if anyone has ever met someone. Do you know the average IQ of the human species is 100? That's how they define it. It's 100. That's the average IQ. If anyone's ever met someone with 100 IQ, you'll soon realize they're incredibly dumb. And here's the worrying part. 50% of the population of the Earth is dumber than they are.
Yeah, well, you're oversimplifying things a lot, because even people that don't have that type of rational intelligence still possess a lot of talents.
No.
And they might not hold up in certain situations, but in other situations they thrive.
When it comes to science and physics, he has absolutely no idea what he's talking about. He knows it.
Paper, IQ isn't everything.
No, I didn't say what.
No, I mean, someone.
It's a measure. It's a general guide to intelligence.
And it's
someone
no,
who no education.
No, it's just a quickness of insight and grasp.
No education.
It's called common sense, is what it's called. Come on with it.
Education, the physical sciences, and they get Dunning-Kruger effect. They think they know everything because they've watched a few stupid YouTube videos. They think they can debunk all of science. It's utter bull crap.
Like paper. Just for an example. I took an IQ test and my friend took an IQ test. My friend, he's amazing. I love him. He's cool, but he's an idiot. He scored higher than me.
Uh-oh.
Yep.
Ding, ding.
Intelligence is no bearing on knowledge. I agree that. But when it comes to the lack of ability of learning, that is a reflection on IQ. It is a cognitive...
That is true, but only in the speed.
Yes, but when
because age brings wisdom with everyone.
Someone's starting to say this can't be possible because of this. They have no idea.
Unless you're brainwashed like you, okay? That's what the problem is. So you got to break that brainwashing that you've been under.
Yeah, but
you need to get some water. Go in the bathroom and get the faucet in there where it'll drip. You need to go. You need to go sleep. Go sleep somewhere where the water's dripping in.
Now here's the contradiction. Flat Earthers
are you need to go. You need to go listen to some water drip for about 25 hours.
No, flat Earthers are typically science deniers. They deny all of science.
Deniers.
They sit there in their
We're not denying science.
They'd sit there
We're
in
heretics.
room, sitting on a computer that is performing hundreds of millions of mathematical calculations.
The intellectual heretics.
Based on the science and based on the innovation of people who invented these computers and produced them, and sit there using these computers to spout their ridiculous perception of knowledge when they have none whatsoever. They think that actually people who actually go and get an education is a total waste of time. They think they can shortcut education by watching YouTube videos. They have no idea about
people learn every day because you read a book. Because you read a book for 300 days. That make you smarter than somebody. All right.
Well, it actually does, David. It actually does.
Hey, I've read the encyclopedias myself. We got them when I was a kid. So
well, which ones? Which ones
every
did
day
you read?
by doing. You know what doing is? Wait,
David,
Lewis.
It's by reading a book you gain knowledge.
It's just like figuring out. I figured. Go ahead with it.
You gain knowledge and both brainwashing.
No.
Lots of science books are filled up with brainwashing.
No, because when you
assumptions and everything.
When you actually get an education in the physical sciences, you actually perform experiments yourself. You know, do you think that when people go and do a 4-year university degree, they sit there and just listen and just absorb bullshit by
every person you meet to be smarter about something than you are, okay? Every person you ever meet will know something you don't know.
Right, sorry to interrupt you guys. Can I just give a proper introduction? I'll just turn you down. I just want to give Lewis a proper introduction. How are you doing, Lewis?
I'm good.
And they learn things. They learn about the physical sciences. That's how these people go on from these degrees, and then go on to become good scientists. And they invent things. They innovate. They invent new computers.
Are you triggered?
Sir, there are a lot of smart people in this world.
Yeah, there are a lot of smart people, David.
You are not.
There are a lot of smart people in this world. No one ever claimed. I've never claimed to be the smartest person or anything like that. You're trying to say that somebody. You try to turn this around to IQ. This has nothing to do with IQ.
No.
Okay.
You admit you're not particularly smart, but you think you can debunk all of science.
Ask yourself a question, David.
No, don't mute him. Don't mute him.
You
Lewis,
don't agree
don't
with
mute people.
science. You think
I never
a lot of
said
it's
that.
wrong.
Did you ever hear me say that? I never said that.
All right, ask yourself a question. What have you contributed to the technology and ease of living to everybody around you?
You know that lies are a great source of ease of living, don't you?
I've hauled a million miles of cars, okay?
But could you make any of those cars?
Oh, I can work on every single one of them, Lewis. I could build the parts for them if I had the money to build me a parts house, okay?
Would you want to? Do you have a desire to? Did you come
up with what I got to do when I live in the real world, Lewis. I live in the real world, Lewis.
David. Did you come up with the design?
Don't answer to nobody, Lewis. It don't work like that.
David, did you come up with the design for them in your mind before you saw them in the world?
Many times.
Many times. Really?
Many times.
Why aren't you on the panel of directors?
How about for computers? Did you come up with the design for how computers function?
Nothing for computers.
All right. So I mean, wouldn't you say that
web addresses?
There's a huge lack.
Here's a good one. For your contribution. You ever hear of that?
There's a lot of people who have contributed to the world, and you have not participated in that contribution.
You don't know that.
I think that's unfair.
Yes, I do.
Really, and I think
he's contributing.
I think
now,
the premise of this. I think the premise of this conversation.
Do you know how many billions of dollars I've sold in my life?
I haven't spoken.
I'm talking about $1 billion worth of cars.
I haven't spoken. The minute I speak, you interrupt me. I think that it's true what you're saying, that science is valuable. These technological advances are valuable to us, but it seems like you're just totally writing off, anyone who isn't academic and as providing no value, and that isn't true.
No, it's not.
And I could give you. Hang on, nearly there. I could give you dozens of examples. Everything from a great painter to a great footballer to a great musician to a guy like David who spends his day doing laborious tasks that many of us might not want to do.
Sure.
It all has value.
Of course it has value, Jeremy.
Sure. Those cars are no good if someone can't transport them to be sold, right?
No one's denying that, Jamie. What we're saying is, I know absolutely nothing about grocery. So I would not go on a grocery farm and start telling people who know about grocery that they don't know what they're talking about.
Well,
I silly of me.
I think that's.
It depends on if you bought the farm, you might. Okay, if you own the farm, you might do that.
If you own the farm.
Hey, I mean.
You might run the farm into the ground if you did that. If you bought a farm and knew nothing about it, and then run around telling your workers that they didn't know what they were doing, they might write you off and undermine the business.
It's like an Arabs getting in the Mexican restaurant business. It just doesn't work.
What?
Yeah, if I had $100 million, I could start a company that promotes something that's completely wrong, and ultimately that company's going to fail because it's going to contribute nothing, because it's going to prove nothing, it's going to innovate nothing. It doesn't matter how intelligent I am. If I'm on a worthless cause, it's a worthless cause. If you know nothing about physics and mathematics, what is the point of you trying to debunk physics and mathematics against scientists who have done this and have spent their lives?
Because ideas are reality, man. And I ask you many questions you don't know the answers to, but you believe in stuff, all right?
What questions have you asked that we didn't know?
1,000 questions he don't know, okay? I can ask him 1,000 questions he don't know.
Ask one question.
How do you know the sun and the moon aren't the same size?
Oh, God.
Because of trigonometry.
Yeah.
Okay, there we go then.
Do you know trigonometry, David?
I don't want to get into it now.
All right, that's fine. Ask another question. That's fine. That's fine, David. Ask another question. Ask another one.
What other flat earthers are on here? Just me and Arwen tonight?
Yeah, I guess so, Dave.
Just you and Arwen. Do either of you know trigonometry?
Just don't let them get to you. Don't worry about it.
Maybe you could explain
we're not
Louis.
trying to get to you.
Could you explain to him?
I don't want to get Lewis riled up. Lewis likes to get riled up. I don't want to get
Hold on,
riled up.
David.
Nothing you do
David,
is
you've asked a
based
good
on
question,
denial.
and now Louis is giving you an answer. He said trigonometry. Maybe he'll expand on it and explain how trigonometry explains how the sun and moon are at different size.
Yeah, you use triangles and the ratio of their sides and their angles to deduce distances and the lengths of unknown parts of the triangle. That's the long and short, or that's the short of it.
You got a video you can show us or something?
No, I went to school.
There's probably a YouTube video about it. I mean,
yeah, there probably is a YouTube video.
Okay.
Go watch a YouTube video on trigonometry. I just did, Arwen.
No.
Wait.
You described it. That's not an explanation.
Yeah, it's good enough. It's good enough for the purposes of this conversation. And yes, it is.
You're using this terminology all the time. Well, prove that you actually understand it.
Lewis,
you don't understand it at all, and I'm saying that's
teach us
what you would
then.
need to
You're
understand.
such a smart,
We're
wise
not
guy.
here
You
to
studied.
teach you
Well,
trigonometry.
Right,
I do
I'm
not
to turn you
claim
all
to
down.
be
I think
smart.
you're all getting a bit over the top. So we've been joined by Multi Tom Tom. Very pleased to have you here, Multi Tom Tom.
It's.
Yeah, I was gonna say.
Hello.
Welcome new people.
It's
just
quite
literally
ridiculous.
I need 2 seconds
you're denying
where you
it,
don't talk. Literally, that's it. How you doing, Multi Tom Tom?
Yeah, I'm good, Nathan. How are you?
Very good to have you here. Thanks for being here. Thank you for your patience, other guests.
I came to listen to Louis's trigonometry class lesson. Louis, can I ask you a question, please?
You could have listened from the audience, but sure, go right on.
Who and how they calculated the distance to the sun?
Yeah, they use trigonometry.
Maybe you could expand
do you know
on
how
that a
they
bit,
got the baseline?
The baseline, yeah, they measured the distance between 2 points on the Earth. And then they would have used that to discover how far they'd moved in relation to the sun. And that's another leg on the triangle. So they can do a number of different calculations to get different bases.
How does that prove the distance, really?
Because you use the ratio of the sides, and then you use that ratio to find
you get from that is an angle.
In combination with angles.
Yeah, but the angle's all you're gonna get.
No.
How does that prove the distance?
One key portion of trigonometry is understanding that all the angles add up to 180 degrees, no matter what shape or size of the triangle you have. They add up to 180 degrees. That's one of the first things you learn in trigonometry.
So,
if
so
you
how
don't
does that...
understand,
sorry, Kurt. Sorry, everyone else. I just want to sorry, guys. I just want to round this out. Sorry, bear with me. Hold on, Multi Tom Tom, because the original question was, how do we know that they are different sizes, Lewis?
Trigonometry. You use trigonometry to figure that out.
Yeah, so far we've got down to them being the same size as they are the same angular size.
Well, that's fine. I mean, I don't really care. I'm just letting you know that's the short answer.
Don't care. You've been asked a question. You've got very rude, and now you haven't answered it.
You guys. I don't care if you don't understand.
I do understand. I understand completely. But what I do understand also is that so far you haven't answered David's question. So you call him stupid. You haven't. Hold on, paper.
And by the way, I'd just like to say that there are hundreds of questions and hundreds of points that we make to flat earthers which go completely ignored, right? Entirely ignored. They get glossed over. And you, Nathan, don't press the issue ever. I find it quite interesting that now you choose to press.
So how do we know the different sizes? I will press this issue then, Louis, because you don't want me to.
Yeah, you're free to press whatever you like.
How do we know they're different sizes?
My energy, your garbage.
That was his question. That was his question.
A debate, Nathan.
It's a very basic question we ask.
He doesn't want to answer. He's dropped. I love it. Very good question, David. Must admit, very good question. Maybe someone else will give you a decent answer.
I think I can help. I think I can help answer David's question. Possibly.
Hold on 1 minute. What? Is it? He's left. Is he? He's gone. I wanted to ask him.
No, I'm here now. I just got up there for a second.
No, not
Nathan,
you.
Nathan,
Lewis.
Since Lewis has gone, would you like me to answer the question? And are you prepared to listen to the answer?
Absolutely, yes,
Lewis
please,
cuss
Paper.
again
I'd
or
love to
what?
hear it.
He hurried back to studying.
No. Are you prepared to listen to the answer?
I mean, okay.
Lewis get kicked out again.
Nathan, triangulation was used to measure the distance and can be used on a daily basis to measure the distance to the moon. The same triangulation equations will show that the sun is very, very much further away. It really is as simple as that. You use triangulation to measure the distance of the moon from two observers, a couple of thousand miles apart, using basic mathematics to prove the distance to the moon using angular size.
We have a new person.
Are they not,
it doesn't work because
are they not the same? Are they not the same angular size?
You can't get the initial result was the 97 million, right? It's not 93. They've throughout the years they've reduced it bit by bit. That's how we came to 93 million. There is no way you can get a baseline to an object that's 93 million miles away. It's impossible.
Cassini in the 17th century, they had an element of error in that because they couldn't measure certain distances so precisely as they can today. We know very accurately the distance to the moon today.
I'm still a bit, but they're the same. Sorry, call me stupid, but they're the same angular size, are they not?
That has nothing to do with it. Riley's got you really confused on this. Riley is absolutely lying about the angular size stuff.
What point are you trying to make, Nate?
Where's Riley at?
If they're the same angular size, how do you determine which one is bigger?
Well, no, because you haven't obviously listened.
Well, I've heard the same thing you said. You've said pretty much the same thing as Lewis did.
Doing the same thing as Lewis was.
You said exactly the same as Lewis, in fact.
No, he did not.
Okay, well, maybe if you repeat it, I'll hear the nuances that I missed.
Okay, you take an observer on one position on Earth, you measure its azimuth and altitude, etc. You take another observer at a different position on Earth, and you take accurate measurements of its azimuth and altitude. From that, you use triangulation to determine the distance to the moon.
No.
Yes, you've said the same thing again. You've said the same thing again. So, with them both being the same angular size, how do you determine the difference? That would give you the same. Sorry, you're all interrupting me while I'm just trying to get clarity. I just want to get clarity. Is that unreasonable? Would that not bring them both out to the same size, as they're both the same size in the sky?
Angular size is not a part of this calculation. We're not concerned.
Explain where the calculation
size.
Differs.
Right.
We're looking at the length of the size.
Is that if you hold a 5p piece up at arm's length away to the moon, and it perfectly obscures the moon, are you saying that the 5p piece is the same distance away as the moon? No, you're not. That would be silly, wouldn't it?
Again, angular size is not part of the calculation for the distance. The distance is the length of the sides of the triangle from each observer
looking at the object. The center of the moon from one position to the moon from another position.
So it have to be from one side of the ball to the other side of the ball at the equator, right? Is that what you're saying?
It can be. Does not have to be.
But that's why you do it, right?
Wow.
Does not have to be. It can be.
I'm still stuck on the same point though. So if you take those two distances across your however many thousand miles.
Yeah, I know you never learned it in school, Nathan. You're always going to be stuck here.
No, this is just basics.
Hey, let's keep it civil here.
So yeah,
well, he's not. Nathan isn't being civil.
So where does the measurement?
You don't get in trouble over there.
Where does the measurement
Lewis,
differ?
If you don't think people are being civil, you should then be the bigger man.
Oh, Lewis is clearly frustrated because people who
don't be talking to Lewis like that.
In geometry, trigonometry, and physics are trying to call out people who have. That's why he's getting frustrated, because he's done the work. He's got the education. That's why he's getting frustrated when people have no knowledge of it whatsoever, saying, "Oh, well, that just doesn't prove a bloody thing." and that doesn't prove this.
No.
That's
Well, just call me. You're fine to call me stupid. I don't mind. I don't mind, Paper. If you want to call me uneducated and stupid, that's fine. But I just want clarity so that I understand it. How does the measurement differ when you're measuring the sun?
Nathan.
I'm not even going to get to the end of my sentence before Lewis interrupts me.
No.
How does the measurement
you need to go
differ?
take a class.
And again, how does the measurement differ between the two different objects?
Right. Well, if you'd listen, Nathan, one person takes a measurement of the position of the moon from one position on Earth. Another person takes the position of the moon from another place on Earth. And with fairly basic mathematics, you can do the calculations and work out the distance to the moon.
No, you can.
Right, hold on, Arwen. Arwen, for the love of God. Hold on. Right, I understand all that. Right. So my question was, how does that differ if you did that for the sun? How would the measurement be?
The angle that you actually achieved would be astronomically smaller.
But they're the same angular size in the sky.
That doesn't matter, Nathan. We're talking about the change in position. We're talking about parallax. We're talking about the change.
Yeah, as long as you don't know the distance,
hold on, Arwen.
Hold on,
Arwen. I very rarely get involved in any conversations. I just want to understand myself what the difference is between the two measurements. Now we've got.
Okay, here's a perfect example. Imagine you remember the eclipse of August 21st. Remember that? You remember the eclipse?
Nathan?
Yeah, I'm listening. Do you want to just make your point?
Yeah, I'm asking you a question. Do you remember the eclipse of the 21st of August this year? Yes or no?
Yes, go ahead.
I want to hear Nathan say yes.
I want to hear Nathan answer the question. Do you remember the eclipse?
Get to your point.
No, answer
the question.
Do you remember the eclipse?
He'll get to his point once you answer the question.
Nathan, you're going to make Lewis mad. You don't answer.
Nathan, just answer the question.
Nathan says yes.
Nathan, just answer the question. Do you remember the eclipse of the 21st of August this year?
Okay, Nathan, do you remember any eclipse? Do you know eclipses exist? This is a very basic question. Yes or no?
Every month I heard.
Okay, let's just say
Nathan,
yes.
Do you know eclipses occur because of the moon?
We need him to say yes to this so that we can understand we're on, at least some sort of equal ground to start the next part of the conversation.
Nathan, are you there or are you not?
Sure, I'm trying to listen to your explanation for how the measurement differs between the two.
I'm asking you a simple yes or no question. Do you remember the eclipse of August 21st this year?
Okay, let's just assume
Nathan is not going to answer the question.
Okay, I'll do my thing then.
Just
Nathan,
give them what
I'm just going to assume that you remember the eclipse because you're not brain dead.
You don't know that, Joseph.
He's not in a coma. Let's put it that way.
Okay, he is not in a coma. That's true.
Yes. So I'll assume that you remember it, because if let's say they were the same size, that would mean that they'd have to be the same distance away from the Earth to appear the same size. Now, if we think of an eclipse as the sun or the moon passing the sun, well, that couldn't happen if they're from the same distance. They just bump into each other, but they don't. One goes in front of the other, meaning that they have to have different distances. And if they're generally the same size from our point of view, that means that they have to have pretty big differences, and they have to be different sizes. So that's how a very simple way of knowing that they're different sizes.
All based on the theory
the question was not answered yet again. No, the question was not answered. That's just inductive reasoning, I'm afraid. So how does the measurement differ between measuring the... I'll ask the question again, maybe Paper answer.
Let me go back to my original question, Nathan. Nathan, do you remember the eclipse of August 2017 this year or not?
Paper, he's obviously not going to answer. Can I just...
He's not going to answer. I mean, does that not...
Can I try my thing with
people?
I mean, Yeah, that demonstrates that they're not the same size quite clearly.
Yeah, Nathan,
why? Where it was totality in one place, 2,000 miles to the east, there was not totality. It was partial. That means that one object is closer than the other, and moving 2,000 miles to the east means that you're looking to the side of that object, and you're seeing the sun.
Can we see your scientific measurements?
David, I just want to get to the end of this point with a satisfactory answer to my question, which I still haven't had, which was about trigonometry and how we measure the two. And now we're talking about eclipses. So my question again, I'm going to be talked over. I've patiently sat and let you ask me pointless questions.
David, Nathan, all flat earthers present, the way we get the various measurements.
Yeah, you weren't involved in this conversation, Lou. You dropped after being asked this question. You dropped like a coward. So do you mind, Lou? Do you mind, Lou? Let the big boys talk. Lou, you dropped, my friend.
The way we get the
now
measurements,
Paper's attempting it, Lou.
Now
Paper's attempting where you failed,
One
Lou.
of those observations
where you failed.
is the eclipse.
Paper is now attempting where you failed. So if you want to keep your mouth shut while the big boys talk, Louis,
just because I failed,
keep your mouth shut. We've already seen your failure, Lou. You smile away, my friend. Now let Paper have a go. I want to know the difference in measure.
It's true.
Son of a bitch.
No, you failed miserably.
Can I try to take over?
Angular size.
Don't be muting Nathan.
Me, you get ejected.
Can I just take over with Nathan real quick? I just want to try my hand at this.
Go ahead.
Nathan, what is your question?
My question is, how does the two measurements differ?
So
sun and the moon. Trigonometry is the base of your assertion of their measurements being different. So far, not so good.
Oh, so do you want to know the actual measurements of the moon and the sun? Is that what you're asking?
Maybe you should take a leaf out of what Paper said and listen. Listen a little bit closely.
Nathan,
I won't repeat my question. I'll just go on mute and let you guys fail a third time, fourth time, and fifth time to give me a decent answer. Maybe ask me a few more pointless questions along the way.
I want to ask you. No, Nathan.
I'm just trying to make sure I can understand what you're asking me, so I can give you a good answer. What are you talking about? The measurements, the angles of the triangle, the distance of the Earth to the moon and the Earth to the sun. Like you want numbers, or do you want us to explain how to find those measurements? I'm not entirely sure. I'm sorry if this might be my fault for not understanding.
Well, yeah, all the millions of miles and all those
you guys are not answering his question. Paper, I want to ask you, do you know how they measured the distance to the moon?
Do I know?
Is that what you're asking, Nathan?
Yes, I've explained this several times.
I'm sorry. I have Asperger's, so I'm not very good with understanding things. So if you can make it a little clearer, I would appreciate that.
What?
Like I'm asking Nathan, what measurement are we talking about? Are we talking about the measurement from the measurement of the moon, like how large it is? Are we talking about the measurement from the moon to the Earth? Or are we talking about measurement of angles?
The triangle, like the angle difference over the same distances with the sun and the moon.
Okay,
are they the same or are they not?
So, is the
pure angle, no distance involved?
Are you using a longer stick or a shorter stick? When you do the moon, do you use a shorter stick, or when you do the sun, a longer stick, or what?
Okay, exactly. So you're trying to, is the angle to the moon for hypothetical 5 degree and the sun is 8 degree? That's the question. Just hypothetical.
The triangulation differential.
Oh, okay.
One spot you measure the sun, in another spot you measure the sun at the same time, then you have an angle difference. Then you do the same thing at the exact same locations with the moon. Are they the same angle differences or are they different? That is the question.
Okay, so are the angle differences on the Earth? I'm sorry.
Well, yeah, that's how you measure that.
Okay, so if you're in the same place on the Earth, if you measure from 2 places the sun, and then from those exact same places you measure to the moon, the angle from the Earth to the moon would be different, and the Earth to the Sun would be different. If you're talking about the angle,
no, only the differential between those two locations. So where the moon is supposedly, or where it's going to be seen, one location and the other, and then the sun in that location.
Oh, okay. I think I understand. I think you. So if
is there a difference?
If I understand correctly, what you're saying is, if you're in two different spots, is the moon in the sky? The moon in the sky is in two different places.
And no, David's question. Maybe David can ask the question again. David, do you want to ask your question again?
Go ahead.
Sorry, I just.
David's question was, how do we know they're different sizes? The sun and the moon. That's a fairly simple question. That's where this all began. That's the question. Simple. Let's see how long this silence lasts.
Can you repeat that? Sorry, I'm doing.
Do you really need this question again? Are you kidding me? Are you serious? For the love of God, pay attention.
I'm sorry.
Grind it down to if there's an angle difference, then you know. If there's a difference, then there is something different.
Well, we need to see the work. Like, we need to see the numbers that go into these calculations. This is why people are supposed to show their work anywhere, so that they can go back through the work and be like, okay, is this calculation based off of this correct? Because it seems like the calculations are based off of the idea that the Earth is wobbling, and you're seeing parallax from the Earth wobbling back and forth.
No,
if the Earth isn't moving, the basis of the calculations are totally off.
That's way beyond that.
All of them out.
You start out with just measuring the angle.
That the sun is millions of miles away, when maybe bad calculations built off of bad calculations, built off of bad calculations. We need to see these numbers and where they came from.
Well, that's an if statement. Any of us can make if statements. I can say, okay, if we're completely wrong about biology, where does that start from? What if our entire knowledge of cells is wrong because our entire knowledge of molecules is wrong? What if, and then our entire knowledge of molecules is wrong because
you'd think there'd be a scientific equation for that, wouldn't you?
Sorry to interrupt you guys. I just want to introduce Huey and Arrow. We've already heard from. How you doing, Arrow? Good to have you here. How you doing, Huey?
Nathan.
Bear with me just 1 second. How you doing, Huey?
Hi, Nathan. I'm doing fine. How are you?
Good to have you here, my friend. Thanks for being here. Pleasure as always.
Nathan, you still haven't answered my question.
He's not going to.
Why won't Nathan answer my question?
Because
it's supposed to be a fair chat.
Why won't he
answer my question? All I asked him was, does he remember the solar eclipse of August? That's all I asked him.
It's a distraction. You don't need to go there.
Yeah,
it's ridiculous.
He won't
He's asking a base measurement question, and all of you just refuse to answer it.
Okay, well, I don't understand what measurement I want, but that's partially
angle difference. Is there a difference between the observed triangulation, according to your system or whatever system, of the moon and the sun?
Yeah,
or are they exactly in the same angles?
Hold on, we've got Huey wants to have a bash.
I think his original question was, how do we know the difference between the sizes?
Yeah, but you start out with this.
They look the same size. How do we know
are they the same?
Hang on, Arwin.
Huey's right. Huey's right.
Shut up. I think his original question was, if they look the same size, how do we know that one's bigger than the other? I think that's what he said.
Yeah.
Well, the basis of the math is pretty. Seems to be similar triangles. A wobble of the Earth is assumed, so you get a different angle in these faraway stars, supposedly by the Earth wobbling back and forth. But if the stars are moving, the motion of the stars could come from a totally different mechanism. Therefore, that gets rid of parallax totally. And then that's an error point right there. Another error point is the fact that people assume the width of the Earth. If we haven't explored all of the Earth, then those calculations that take into account an inaccurate number for the diameter of the Earth or this parallax for these similar triangles will be off. There's another error point right there. And then a lot of times it looks like these scientists just take a baseline measurement of the assumed distance of the sun, which might be incorrect, and use that to base other triangle calculations. So that's another error point right there.
I see what's going on here. You want to feel special and smarter than everyone. Okay.
Oh, that's unique. Only flat earthers do that, right?
No, what I'm saying is that you're taking what our argument is, which is science is correct, and then you're just going, Goodbye. So you're not going to even consider our argument, because our argument is based on the opposite of yours. Your argument is based on that science is not our scientific measurements are wrong. Ours is based on it's right. So it's completely. If you're going to say it's
based on
wrong,
the measurements, it's based on the assumptions that are wrong. Yes.
Okay, but
the
you're
measurements
saying
are there. You're just using the wrong formulas. You're
okay, then what
the
formula should we be using?
Ding ding knockout. Good job, Arwen.
What formula should we be using?
That's your favorite phrase.
Well,
You're such a retard.
I like that phrase, David. I personally like that phrase.
Okay, well, my model is that the heavens.
Your model.
My model.
You're smarter than everyone else.
No, I've just been thinking about this a little bit broader.
Why is your model the correct model?
I don't know if it's the correct model, but it seems to be working really well so far.
But my model says that the Earth is a centimeter long. It's working out great for me because I'm basing all my other measurements off of that measurement. So if you base everything off of one thing, that thing's
the thing is that my model is not really based on like literal measurements in the sense that like the literal distance. No, it's more conceptual in nature. It just switches certain perceptions around, makes you look at it in a different way, and it works out. It pans out.
Okay, but the model we have right now in science also works out with what we know.
No, it doesn't. It's just really, really fast.
But it does work out.
No, it
That's
doesn't.
why
It's full of holes everywhere.
Okay.
It's all
the
just
model
based.
of the Earth.
It's all built around the religious assumption of the theoretical model.
I'm sorry. There is no religious assumption. What does religion
religious
tie
assumption?
Where does religion tie
You
into
constantly try to build like corks for this? Holes everywhere.
No.
It's become a giant space station of corks.
Hey, where does religion fit into this? I asked you a question. Answer me.
If it's wrong,
you
just keep on building to make it right.
No. Where does religion fit into this? You said something about religion. Answer that question before we go on.
Well, religions are based on visions, on certain things.
Hey, Arwen, this is a flat Earth
Please,
debate.
David.
It's not about religion over here. Get it back on flat Earth.
The globe isn't, David.
Yeah, I understand that.
It's about religion. That's the whole.
You don't know that. There's a lot of people that have just been brainwashed into believing it, so you can't say that.
Religious. It's religious in that the world.
You never
People
talk
just
about
don't know no better.
You're a troll, David.
Hey, I want to hear this. I want to hear
that with them. They're trying to put you in a corner over there.
No, I'm not trying to
put me in a corner,
David.
You're assuming my weakness. Thanks for that.
I'm not doing that. I'm just telling you.
I'm not trying to put anyone in a corner. That is not my intention.
Stop it. Go away.
It's Arwen and David. If it seems like I'm trying to be attackive, I'm not trying to. I want to understand your position.
Yeah.
Here, let me. I want to screen share something. Let me screen share something here real quick, Arwen. Here you go.
You're a troll.
What's wrong with this map right here?
What's wrong with it?
Let me see.
Well, it's a projection. That's what's wrong with it.
Okay.
Just like all the other maps.
No, it's their globe map. That's what this is. It's
Getty
Images.
Stupid.
It's the most current Getty Images map of the world right here.
Between South America and Australia. That's what's wrong.
Okay, as David's presenting an azimuthal equidistant projection, I think I'll use this opportunity while he gets a barrage of insults to do a few links. So thank you to everybody who has shared this stream. We have a little over half an hour left. So if you did want to join the panel and express your views on the shape of the Earth, simply click on the link in the info box below this video. Be sure to mute the page you are currently watching before you do so. If you wanted to support this channel, toss me a buck or two in the super chat. And bear in mind, if you join the show, there are a couple of rules. Number one, please do not swear. And number two, if you do, you will be ejected. So please do not try to rejoin the stream using sock accounts. You'll be warmly welcome back on the next stream. One more time, please share the show if you've not done so already. And once more time, if you've not subscribed, be sure to hit that subscribe button and the bell notification icon to keep up to date with the Flat Earth debate.
Why is it on a flat map right here?
Because you can't make a three-dimensional object.
You see any water on here? This has all your time zones in it, doesn't it? All your time zones. All the water. If you mapped out your globe, this is your globe, isn't it?
That's one way of mapping it. Yes.
Okay, so we're at on here. Where do you get to the curve on here?
David, it's still a projection.
It's flat.
No, when do you get to the curve? If you turn it into a ball, this is the top of the ball, the North Pole, right?
David,
on a ball.
David, it's still a projection because the Antarctic Circle, the land circle, doesn't fit around it.
A troll is punching you in the face and you still can't see it. It's hilarious.
I know he's a troll, but I don't
ignore him.
He's not a troll. It's the same thing he's trolling about that he has been trolling on for the last so many.
Why does Australia look like this?
The same thing over and over again. Just
is there anybody from Australia on here?
If we ignore him,
where are the Australians at?
Louder, and we can't get actual conversations.
Yes,
where are those Australians? There were some Australian guys on here the other day.
Ignore him. He's a troll.
They say Australia's the closest state on the planet. That's like Texas is over there in Australia.
Okay, but no, Paper. I would ignore him, but if he's going to keep talking over like other people like Arwen, who I actually want to have a conversation with.
All right, go ahead, Arwen.
Yeah, it's all right, David.
Ignore David. He's a troll. He's a professional.
Stop. You're not helping things, okay?
Well, I mean, is he asking at what point you have noted curvature? Roughly 3 to 6 miles out, we're supposed to note curvature if stuff's disappearing. That's noticeable curvature. I mean, I guess you'd have to argue that eyes are pretty sensitive and they can see curves far or near off. But let's just say you take a circle and only take 1/10 of the circle, and you can see the curve on 1/10 of a circle. Okay, you translate that for the globe. That's 1/10 of the globe. We should see noticeable curvature, say theoretically, for 1/10 of the globe's distance, which they say is 25,000 miles. What that's like 2,000, maybe 2,500 miles out. Mm-hmm. We should see, if we see a horizon with a 2,500 mile long horizon on these space stations, we should see noticeable curve. If we don't see that, then where's the curve? How about that?
What do we see from the ISS, and how big is that horizon?
I don't know.
Yeah, and how about that like military radar that can actually scan like thousands of miles away?
Following or not, I'd like to address David's map, if I may. No one has any objections.
You go ahead.
Nah, go ahead, man.
Look at the distance between Tokyo and London on David's map.
Hold on a minute. Let me pull it back up.
Yeah, okay. Can you see Tokyo, David?
I can see it. That's what I'm asking you. That's what I'm trying to tell you. These maps, you can't find. You can't show me a map.
Hey, you're going to let me ask the question, or aren't you?
I understand that. Just show me the map where your map works, okay?
Are you going to
show me a map that looks just like this.
David.
I understand.
Come on, David.
Show me an example.
David, come on. You've asked these questions. Let him answer them. Come on, David. Be reasonable.
Go ahead.
Let me ask my question, David. Now, can you see where Tokyo is on your map? Can you see Tokyo?
Go ahead.
I'm asking you a question. Can you see Tokyo on your map?
Yes.
Okay. Can you see London?
Yeah.
Yes.
Okay. So keep that in mind, and maybe draw a line in your head between Tokyo and London, right? Now, can you see Sydney on your map?
Yes.
Can you see Santiago de Chile on your map?
Yes.
Now look at that distance. Okay?
I don't know.
Yes. Get to the point.
It's about 3 times the distance, as at a guess.
About 3 times the distance. Yet we know that the flight between those two is exactly the same almost, between 11 and 12 hours.
Which flight?
That's what's wrong with the map, David. It doesn't.
Which flight is that?
Reality.
Like in a plane, like flying in a plane.
Yeah, but which flight is that? Because all the flights all go through the northern hemisphere anyway.
With 2 wings.
So that right there is what's wrong with your map, David. That's just one of the things that's wrong with it.
Yeah.
There's no direct flights east to west or west.
Hold on.
They all go through the northern hemisphere.
David, for the benefit of Arwen, could you point out Tokyo and London, please?
That's not true.
Let Arwen see where Tokyo and London are on your map, David. Could you do that?
Go ahead.
London is directly under the middle, and Tokyo is above it.
Using the same technology, we know how long they take. About 11 to 12 hours. I can personally attest to Tokyo, London. That's a journey I've made many times.
Yeah.
It's about 11 to 12 hours.
David doesn't want to play with
It's a straight line.
The aircraft from Sydney to Santiago de Chile would have to.
I've already seen this argument.
Sorry?
This is all basics.
Like, just proved this argument a few times already over here.
What are you challenging?
Mark Sargent talked about this stuff in 2015, guys. Come on, this is ultra basics about the flight path. They all go through the northern hemisphere.
Hold on, Arwen. I mean, if you want to tell the audience exactly how Flat Earth has got around that problem, I'd love to hear that.
Sorry? If you want,
that's a pretty big problem for those who believe in the azimuthal equidistant projection. That's a pretty big problem.
I figured that out over here.
Go ahead, David. Let's hear it.
Well, you have.
Nobody in that country knows where north is. They've got all the compasses messed up over there. They say you have to have a different compass in Australia than you have to have anywhere in any other part of the world.
That's not true.
No, that's what y'all say over here.
No, it's not what we say. That's what you hear.
Yes, it is. And then you look at you look at pictures of Australia, just like in that map I was showing you, and then you look them up on Google. They're completely different. The shape of Australia. Okay.
Yeah, because your map is distorted, David. Again, for the 347th time.
No,
are you Australian, Earth Water?
How long is Australia versus how wide it is?
Are you Australian?
If you go and just answer this question: how long is Australia versus its width?
Look at
the thing is, the map is obviously distorted.
It's twice as long as it is wide, but if you look up a map, it looks like it's the same size all the way around.
Look at the flight times, north to south. Look at the flight times, east to west. You'll find that they're very similar.
I have not studied the flight.
Well, you need to go and do that then, David. Look at the flight times. They're all very similar.
Well, that map would probably illustrate the concept, but it looks like that is distorted. Those sizes most likely are not correct.
No, Australia.
What y'all got to understand, that's the baller's map right there. That's what that is. That's a baller's map. Okay.
Are those sizes correct for the continents? That's the next question.
That's the baller's map. That's That's the map that's been released for all the ballers out there to say that's y'all's map.
Look at
I don't know why you're trying to turn it into.
Hold on. We've got too many people talking over each other. One at a time, please. Come on.
I'd like. You haven't answered my question, and you refuse to answer my question.
That's the baller's map right there. Okay.
My question. Nathan.
I'd like to say something.
Why is that? I appreciate your hangouts, but you absolutely refuse to answer a simple question. Why is that, Nathan? Silence, yet again.
Go
You
ahead.
absolutely refuse to answer my question, Nathan.
I think because he's insulted by, your
I'm just
arrogant attitude.
No, I'm just asking.
You're disrespecting him as a host.
No, I'm asking him a simple question.
You refuse to.
Does he or does he?
He asks you a question and you answer with
or does he not remember the total solar eclipse that went across North America in August this year? That's a simple question I've asked him. Does he or does he not remember it? It's not disrespectful. It's not disrespectful.
Yes, it is, because you refuse to just answer.
No, I'm just asking him, does he remember it? Yes or no?
Maybe we need a new strategy. I mean, we can get pretty proud and stubborn with this sort of stuff. Maybe we just need to move on and come back.
Question. It's as simple as that. I asked him a simple question. He will refuse to answer it.
It's pretty obvious at this point you're not getting an answer, so just
give him... paper. Let's just assume he does. Okay? Now
keep answering means he's just going to refuse to answer you anyway because he knows it'll wind you up, so why are you wasting your time?
Let's just assume he does.
It just means that he'll put himself in a very precarious position of being able to being able to answer a simple question regarding that fact.
Let's assume he does remember it. Continue from there.
Okay. Then the simple question is that when there was totality in a certain part of the United States, several thousand miles to the east, it was not total. It was not totality. There was a partial eclipse, which means that the moon was not at the same distance of the sun. Because if it was the same distance of the sun, it would still be a total eclipse several thousand miles to the east.
They were saying.
And sorry, David. And how does that? Sorry, David. Sorry, David. It's taken quite a long time to get to that answer. So, how does that affect the triangulation measurement paper?
Well, simply because, if they were the same size and they were one in front of the other at one position, Nathan, then how come several thousand miles across, they weren't in the same position?
So do you want me to repeat the question? How does that change the triangulation measurement paper?
Because, Nathan, one of them has simply moved across with respect to the other.
And how does that change the measurement?
There is a difference in distance.
How does that change the measurement when you triangulate it?
How does that affect the... Okay.
Excuse me, Joseph. Joseph, just wait. Just let's hear Paper's answer.
Okay. You've got one position, okay, where you're looking up at the eclipse and you've got totality.
I've heard all this.
You've got the moon in front
of the sun. I've heard all this. You're repeating yourself. I'm not deaf.
Okay. You've got the moon in front of the sun. You move 2,000 miles to the east and the moon is not in front of the sun.
And how does that change the measurement of it?
Well, it shows that the moon is very much closer than the sun.
Well, that's what we call a non sequitur conclusion. How does that change the measurement? How many times have I got to ask this question to you, Paper?
Nathan, if you're standing at one position and you've got a human being in front of a lampshade and you move to the left...
This is a lovely example. Does it change the measurement, Paper? Does it change the measurement or not?
All of a sudden, you can see the lampshade.
It's a lovely story we're hearing, Paper. It doesn't really answer my question very well, though, does it? Doesn't answer my question at all, in fact. So how does it change the measurement? When you triangulate it, how does it change the measurement?
Nathan. Paper. It's okay. If you want to blank me off, okay, you want to shout over paper. That's no problem. No problem. Okay, I made my point.
So how does it change the measurement when you triangulate it, Paper?
Paper, what he's asking is, does the fact that the moon and if you move a couple thousand miles, that it's now a partial eclipse instead of a full eclipse, does that impact the measurement? Does that change how you would measure the distance, or does that change the measurement from the Earth to the moon?
Yes, this is called parallax.
Something you see every night in the stars. Oh.
It's so simple. If you've got one object in front of another, if you've got one object in front of another and you move to the left, and then all of a sudden you can see the object that is behind, it shows that the object that was originally obscuring the one behind is closer to you.
So how does that change the measurement of it, though, Curved? I mean, I can see that you're making a deduction, but how does it change the measurement?
Who?
Does the triangulation of either object change in measurement?
It's simply proving that the moon is far closer than the sun.
So does it change the measurement, though, Curved? You keep saying this. You keep giving me the same answer.
Curved knows the answer. Go ahead and answer him, Curved.
Why do you keep saying curved?
I mean paper. Sorry, Curved. I'm really sorry. I'm used to having this sort of conversation with you.
Okay. All right, just checking. I would like to say one thing about this.
Go ahead.
Because I think I get your point. I think I know what you're saying. Now, with what paper is talking to you about with the moon right now in the eclipse is another demonstration of a way that you can easily deduce that the sun is further away.
Yes, I said that. I realised what he's deducing. Right, I understood that, and I pointed this out already, Curved. I understand his deduction.
I'm not finished yet. My next statement is it does not address directly the question that you've been asking, and I'm trying to help paper understand that you're referring specifically to the two different triangulation occurrences, one for the moon, one for the sun.
Yeah, one of them's 96 million
for a
miles.
mathematical answer, I believe. Is that correct?
That's a pretty way of putting it, I would say, yes.
All right, that's what I'm seeing. That's what I'm picking up on. I've been quiet because I don't study this, and I don't have the numbers off the top of my head to do all this. But I'm just trying to help with the point.
How about a newspaper article where this was decided? How about that?
I'm simply trying to state that when you have two objects, one is obscure than the other, and you move a certain distance to the left or right, then the object in the middle is not obscuring as much the object in the distance. That shows that the object in the middle is closer to you than the one further away.
But the measurement remains the same. The measurement remains the same, though. You don't seem to be getting it, paper. They remain the same.
The measurement remains the same.
They remain the same size in the sky.
But one is.
You're deducing that one goes in front of the other. It doesn't change the measurement, though, does it?
How it makes the shadows
to the other. Oh God!
Can you explain?
Your deduction does not change the measurement.
Measure by the stars or something.
They come out at the same size, David. David, they're the same size. David, they're the same size.
You want the numbers, Nathan? Is that what you're asking for? You want the numbers?
I'm ask the question.
Same size.
Same size.
Same size.
Same size.
Oh, they're not.
Wait. No, guys.
They're not even the same angular size.
Tell me how you know the different sizes. Tell me how you know the different sizes. Triangulation does not answer that.
Well, that's how they figured out by angular size.
Triangulation doesn't give you a different size. They come out the same size. Simple as that.
You're not? Because I never get to speak when I want to speak, and I was going to ask you.
Fixed to shut this down. Y'all got knocked out so bad tonight. Y'all need to go home and take a nap.
This is ridiculous. This is just ridiculous. I've been trying to speak for the last 10 minutes. And every time I open my mouth, someone interrupts me.
Yeah.
Can I speak, please? Can I?
So, how about we let Hugh speak, and then we let...
Hang on. I was before you. I've been trying to speak for 10 minutes.
Hang on, he cuts it off.
I've been trying to speak for 10 minutes, but you all just shut up and let me talk. Please. Nathan, are you asking for the numbers, the specifics for the two different measurements? That's what you're asking for?
Yeah, well, I'm trying to get to the end of David's question, which is how do you know that they're different sizes?
Okay, so I don't have... They're out there. I'm sure you can find out, but if you want the numbers...
Did you really interrupt for that? Huey, come on.
What?
Did you really just bring a close to a load of kerfuffle to tell us that the numbers are out there and we can look for them? Thanks for that. Wonderful.
Okay, do you want to...
Lewis knows. Where's
When
Lewis
you don't
at?
know something, you can find out. That's all I'm saying.
That's lovely. Thank you, Huey. I'm so glad you're here. If it wasn't for you, Huey, I don't know what I'd do.
Well, there's no need for sarcasm, Nathan. I'm just pointing out that
absolutely a necessity for sarcasm. You don't need to interrupt everybody to tell them that they need to look it up. That's just ridiculous.
Okay.
Well, I will. All right, I'll look it up. I'll do it now.
No, I'm looking at...
Yeah, you do that, Huey. You go look it up. Good lad. Good lad.
Hey.
While you're doing that, can you look up when the first time everybody could see the ISS, please?
I looked that up. I couldn't find anything, but I...
Stay on topic, Joe.
You couldn't find anything that we can tell the difference in the moon.
I'm interested to why the moon's shadow is only 70 kilometers wide when it hits the Earth.
Yeah, we can talk about that. Joseph was answering.
All depends on how close the moon is to the Earth.
Can I?
All right, and do it. So our Earth's shadow on the moon when we eclipse the moon is big enough to cover the moon.
Yes.
Okay.
Okay. So the moon, the radius of the moon is 1,079 miles across. The radius is 1,079 miles. The radius of the sun is 432,288 miles across.
How do we know that exactly? Your question is, how do you know that?
How do you know that? That's brilliant.
Come on.
Look,
well, I'm sorry. I was trying to give you answers, Nathan.
The apparent size of the moon and sun.
Can you not laugh at me?
Two different questions when you were
just look it up. I'll just Google it. Sorry, guys. We should have said this at the beginning. For all who are watching, just Google it. Just Google it, lads. Just Google it.
With who do you tell if one is bigger?
Google it, and they'll tell you. They'll tell you. Tell you what it is.
The citations in the group chat, Nathan. There it is. There's the distance of the sun.
Nathan, I was trying to help.
That's how it's done. There's your specific.
How about you don't be a cunt and laugh at me? Because I'm just trying to be helpful. That's very rude of you. And you're...
I'm laughing at you for even saying this. So what are you going to do about it?
I'm not going to do anything. I'm just pointing out that he should not laugh at me when I'm trying to help him.
We're in a room full of people that believe gravity is real. So
yes, and we're also in a room with people who don't believe in gravity. I believe in gravity, but I still respect you as a person enough not to laugh at you for not believing in gravity. Because I feel as though you have a valid reason for why you believe these things.
It's
or
all
things
right, man. They just hid the shape of the Earth to you. It's not that big a deal. It'll be okay. I'm telling you.
And the thing is, trying to fit it in with these gravity models with mass and all these tortured numbers has led to some really effed up stuff. Maybe we need to just go with electromagnetism and density and buoyancy and get rid of these bad models.
Support your assertion. What tortured numbers?
Well, we were talking about the moon being so like 1,000, miles in diameter, and the sun being, perfectly situated 40 times the distance away, with the sun that's 40 times as big, but tends to be 40 times away. That seems like a little too convenient for me. That seems like fake math.
The apparent size of the moon changes, and it changes much more so than the apparent size of the sun, which only varies very minutely over the course of the year.
This is why we get
elliptical orbit.
And this is why we get
I found the information. There's two links in the group chat. One is distance to sun, one is distance to the moon, how it's done, all the methods you can use to determine it. It's all there. Does that answer your question, Nathan?
Yeah, thank you, man. We'll look at that.
Nathan, are you all right with that?
Yeah, it says, although... Can you read it? Is it on screen? Maybe you'd like to read it yourself.
Yes, I can read it right now. Although imprecise...
Sorry, I've got some National Geographic. Sorry. My bad.
So, although imprecise, some word hard to pronounce, provided a simple understanding of the sizes and distances of the three bodies, which led
What was the second word? What was the second word you said?
Imprecise.
That's an interesting word.
God, it's almost like someone can't fucking fly to the sun and measure every inch.
Yeah, that's what people do when they get angry. They start swearing when they start to lose a terrible, terrible debate that they've done really badly in. They start to swear. It's really amusing for the audience. Thanks, Joseph.
Well, I mean, basically what they did is they know about the law of vision, that something that's twice as far away from you as its original position will...
Great link, QE. Thanks for that.
Which method was that, or how long ago was it? Was that one of the original
the imprecise one? Should we dice up this imprecise method a bit more, shall we?
Well, I would just a rough idea. Is this like one of the original?
Who cares?
Attempts?
It's not precise, is it? Who cares?
Well, if it's one of the first attempts, I'm not going to disregard everything that we know today, because the first attempt was kind of characterized.
You do this a lot, Curved. When someone comes up with a crap argument, when someone comes up with a really naff argument, Curved's there to fight it after it's dead. So the argument's dead, and there's Curved trying to fight that corner.
The argument is
maybe you can do better.
Dead.
Maybe you can reference something better that gives us an accurate measurement, Curved. Maybe you can do a bit better than Huey's done.
Yeah, I couldn't read that. I don't know what that was.
It's in the side chat. Knock yourself out.
I don't know. I'll probably have to do that. I'm not going to take it all in tonight and be discussing it tonight. I'd like to know more about what I'm talking about with it.
David's gone. Why is people being booted? Are people dropping or being kicked out?
I don't know.
Scroll down, Nathan, to the section on new equations. It explains how more precise measurements have been taken since.
More precise or accurate?
Well, that's subjective, isn't it?
Yeah.
The thing is, Nathan, you kept asking 2 questions and making it like it was 1. The original question was, how do you tell one's bigger than the other? And then technically you got that information eventually when they were talking, when Paper was giving you the example of the eclipse and to do with angular size and stuff like that. But then switched back to the angle measurement, which was obviously coming back to what Lewis originally said about using trigonometry. So it was 2 different questions you were asking. The basic question, how do you tell one's bigger than the other? Angular size is enough to do that.
So are they different angular sizes?
And the angular size is the same, then the thing that's behind must be further away.
So that's deductive reasoning then. It's not actually changing the measurement at all, as I pointed out then. Is that correct?
Changing what measurement? That's what I'm saying.
The measurement of the angular size.
Just wanted to say,
you just hold on. Everyone's interrupting again. Me and Al were in conversation.
Nathan, I just wanted to say that I'm sorry. I didn't mean to curse. I'll leave right now, but I'm sorry. All right?
So
anyway, we've been joined by the Rumpus. Good to have you here.
Measurement, so you're talking about... Oh, sorry.
Sorry. How you doing, Rumpus? Good to have you.
Yeah, Nathan, I don't understand why you think it's such a problem determining the distance to the moon. It's very easy. All you need to do is to make 2 observations from opposite sides of the Earth, and using parallax and simple trigonometry, you can work out how the moon, the distance to the moon, and you can get a decent approximation. I think I'm just looking at one example there. You can get it within 10-15% with some very simple observations. Whereas if you do the same with the sun, you can determine that it's not very close to us. So just by doing some simple trigonometry observations from different sides of the Earth at the same time on the moon, you can tell it's quite close. And you do the same sort of operation for the sun.
Well, this is the question. Maybe you can explain how. You're just asserting something. So tell us how. Tell us how the measurements differ. So if you do that exact same thing with the sun, how does that measurement differ when you do it with the moon?
Right. Well, when you look at the moon from 2 different well, you could take 2 opposite sides of the Earth.
You've just said all this. We've had this several times, Rumpus. Really? Are you going to join to tell us how trigonometry works again? Really?
Well, apparently I have to, because you don't.
No. You don't have to. We've had it explained several times. Are you not paying attention?
So why are you asking? If it's so obvious that you could determine the position of the moon from the Earth simply by having 2 observations, and you understand that, why do you keep on repeating this problem about not understanding it? I mean, if you understand it, then obviously you don't have to explain it, but you're telling me you do understand it. So you either do or you don't.
Does the measurement change with the sun and moon when you do that exact thing that you've just described? Does it give you a different measurement, a different size for each thing, or not?
No, you are right. You're confusing the angular size, the degree, the size of the moon and the sun in terms of angles in your vision remain the same. But we're not. We're talking about the actual distance. Well, we're talking about the distance here.
And how do you determine that?
Right. Well, okay. I'll explain it again. Actually, I could do a. Well, okay. So I say, if you take a. I've got.
Oh, right. You've suddenly the penny has dropped, has it, the Rumpus? That the 2 things come out exactly the same measurement.
No, the angular
that penny
size,
dropped, has it, Rumpus? Or are you going to tell me how to do trig again?
Hold on, Nathan, I can explain that. You seem to think that because the angular size, you don't seem to understand a big thing a long way away can look exactly the same size as a small thing close to you. You do understand that, don't you? You appreciate that. So you keep on saying the size is the same. Well, it's the angular size. That doesn't mean to say the size of the things are the same.
No, whenever Nathan gets cornered, Rumpus, he doesn't answer.
Right. Well, okay, so let's. Well, I'm going to assume that I assume he must understand this. Perhaps he hasn't forgotten it or something.
No, he doesn't understand it. He's just deciding to ignore it because.
Right. Well, okay. So a big thing a long way away can look exactly the same size in terms of angles. So we're just talking about angles here. The angle that it subtends to the observer, to your eye. A big thing a long way away can look the same size as a small thing close to you. But what does vary is if you move. So, for instance, if you were to look at say an ant in front of you. Say a cat or something, that sort of distance, and then you move 10 feet to the left or the right.
Story time again. We've had this from Huey, and I think we've had it from Paper, and now it's story time by Rumpus. Here we go. Story time. Story time.
What I've just said.
And start to stick your fingers in your ears. Nathan.
Hold on, Nathan. Are you disputing that for a small object, and I move left or right with looking, say, at a cat on my lawn, that the what will be obviously behind the cat will change, whereas an object a long way away of the same size as a cat, say a distant tree that happens to be the similar sort of size as that, when I move left or right by 10 feet, you're disputing that you're not going to get a change of the background relative to the object. Is that what you're claiming?
No, we've already had the eclipse example, and I've said it's. Have you been listening to this show?
Well, what do you don't seem to understand? Do you accept my explanation as to how you can determine the difference between a thing that's close to you and a thing that's far away from you? I've just explained to you how you can do that.
Yes, I appreciate that.
Great.
We've had this explanation before, Rumpus. We've had this before. Have you been watching the show? I've just asked you a question. Are you ignoring my question, Rumpus? Have you been watching the show? Have you been paying attention? Have you been listening?
No. Have you been paying attention,
yes.
Nathan?
Because
if you understood what I just
still haven't got a reasonable answer from any of you. How we determine it? How does the measurement differ? How does we've got lots of how things are different and how you see things that are different in terms of their perspective, and if an ant's closer, and because
the distances of
doesn't change the measurement, does it? Doesn't change the measurement at all.
If you've understood my explanation, you should be able to say, okay, yes, that's fine. But you don't seem to be understanding my explanation.
You've explained already been explained, and it doesn't change the measurements. They still come out to the same size.
Angular size, yes.
You deduce that one is in front of the other. You have deduced that one is in front of the other. That's your deduction. It does not change the measured size.
When you say size, do you mean the angular size? Hold on, Nathan. Let's make sure we're using the same terms. When you say size, you do mean the angular size of something, don't you?
The original question started with, how do we know the different sizes? So tell us how you know the different sizes.
Well, I thought we were trying to tell me there are different distances away from us.
Well, that would be something that would be useful along the way, wouldn't it? That would be useful too.
We seem to have a problem with terms here.
You can tell me how we know the distance. That would be useful too.
Hold on, Nathan. Can I just check we're using the same terms here? When you talk about the size of something, do you mean the angular size as it's subtended to an observer? Is that what you're talking about?
If you've got the actual size, that would be wonderful.
No, I said angular size, not actual size, angular, in terms of the angles that an object subtends to an observer. Is that what you mean by size?
We'd like to know the actual size.
Right, so the angular size...
question.
Right, so hold on, Nathan. So the angular size we accept is the same. The sun and the moon have the same angular size. They in terms of your vision, they occupy the same degrees of vision on your field of vision. So they have the same angular size, right? So we sort of that. So when you talk about size, then there's the actual size. So that is in terms of a linear, in terms of kilometers or something. So one is in terms of degrees, which are the same for both of them. So the moon and the sun have the same angular size. It's 5 degrees, I think.
Approximately.
Right. Thank you. So those two have the same angular size. But if we want to know the size in terms of kilometers or miles or something, right, we then need to know how far it is away. And we can do that by the operation I just described about moving left and right and using then basic trigonometry. Sorry, 0.5. Thank you, Curve. By moving left and right, just like I could work out the distance to a tree.
They come out at the same size, though. They come out at the same size.
Angular size. So hold on. Nathan,
so you're saying that you measure it again and somehow it comes out to a different size by measuring it again, triangulating it again? If we triangulate it a fourth time, maybe it'll come out to different sizes again.
Or you talk about distance.
Please interject for a second. Please let me interject for a second. Nathan, You're standing at a position, and you view in your distance. You view a car. You're looking straight forward at 90 degrees.
Sicker story time. And with that, I will say a huge, massive, enormous thank you, first and foremost, to the live audience for joining in with this debate in the chat. It's been fantastic. And of course, a massive thank you to all of the panelists for making this debate possible. Be sure to like, comment, share, and subscribe. I've been Nathan Oakley, and I will see you all in the next video.